have you all here. Today we're going to talk about CI CD for data and how we could use Lakefs to build test data environments. I mean, are you all data practitioners, I'm assuming? Anyone in the data engineering space? Or data science? Or anything to do with, anything else to do with data, probably the rest of us? Okay. Why I asked you is because I come from a data engineer background, and most of our days, what you would expect to do is, be done with it Friday evening, post 3 p.m., no work is getting done. It's just the data pipelines up and running, let's go grab a drink. But then what actually ends up happening is this, mostly on the Friday evenings, because your weekends are not supposed to be having fun, and it is supposed to be to put out the fire that has been done by somebody else on a Friday evening. I mean, if you think about all the problems that as a data engineer one has to fix, it's like literally nonstop. It goes on and on and on, starting with, the infrastructure upgrades one has to go through with Spark and EMR. Like, we are here talking about AWS services, obviously. So I'm sure you would have worked with EMR and the, challenges that come with it as a data person. And then schema changes, business logic changes, infrastructure upgrades, and whatnot, right? With also a little more on the, backfilling and late arriving data and all the data challenges one has to face. And so we all agree that there is a lot of challenges as a data engineer or a data practitioner that we face. So what about it? Like, what are we going to do about it, right? Like, is there an effective way to go about how do we fix them? Or what exactly is that we want to do? I mean, we do all these, data changes that are coming in. But to effectively handle them or tackle them, what you want to do is, after resolving all those problems or after putting out those fires, you want to test those changes or the fixes in staging before it actually goes into production, right? But then, do we actually do a lot of testing in data? Not a lot. Some of us do unit tests, and some of us try to do, come up with a little more elaborate testing strategies. For example, black box testing, or even some advanced data teams have set up continuous integration and continuous deployment of, data as well. But to do all of these testing effectively too, we need data, right? And what do we end up doing with the data? We start with a very simplistic strategy of, let's just mock some data, right? A couple of records, a few hundred records, just go about testing how our fixes are going to be, effective or not. But then once you do that, it's not going to be fully reflective of how the real world data is. So what you also end up doing is, let's go copy all of the production data, put it into the staging environment, test our fixes, see if it's fine, and then promote the, changes into the production. But then these are on the two extremes. Mock data is too simplistic, but copying production data around causes a lot of liability issues if you think about it. Because if there is PII data around, we're copying it out of production, putting it all over the places. And now instead of just one place, you need to be, aware of your data security issues in multiple different environments, which are all in silos by different engineers and different teams across the company. An effective middle ground has been so far about, sampling the production data, just, copying part of it. But that still does not solve the challenges that come with, data security and, I would say, governance issues that come with, copying the production data. So how does one go about managing this data specifically for testing the data pipelines, right? How does one go about managing the data? Before we even go there, we need to understand what is the data lifecycle like, right? If you think about it, given the data privacy regulations that we have, like GDPR and CCPA and everything, the data cycle does not just start from ingestion, transformation, and loading it into a data warehouse. It starts much before that. Data creation all the way to data deletion, like the right to be forgotten workflow, if you're familiar with, for example. So the creation of data, ingestion, transformation, and processing, and everything else. And then, consumption of data by different data consumers within the team, internally and externally with customers as well. And in the end, also deleting those data, thus coming a full cycle of how one manages this data across these life cycle, right? not all the data teams are mature enough to figure what effective data strategies or management strategies can be used for this complete life cycle, which is exactly where the CI CD of data could come in to help data teams manage data effectively throughout its life cycle, from creation all the way to the deletion, which is exactly what we are here to talk about. Maybe if you wanted to have a quick look at this, like ingestion, transformation, testing and deployment, yes, and monitoring and debugging, because most of the times, even after the data is being, you tested it enough, pushed it to production, it is still not, it is still not away from all the errors and the issues that happen in the production. So you still need to monitor and debug and troubleshoot all the issues that would occur in the production to keep a hold of good quality data, which is reliable and trustworthy for your end consumers as well. And if this is how it looks, and it's not just this, right? Like on the ingestion side, there is data coming from different sources, and on the consumption side, we have concurrent teams consuming data from, sometimes from the same sources and sometimes in terms of different data products. It could be a BI dashboard, it could be a data warehousing tool, or it could be anything else as well. So to manage this effectively is why we're going to CI CD for data. Now that we understand that there are challenges, and to manage data effectively, we do need CI CD, but then how are we going to implement CI CD for data? What exactly does it even mean? Because CI CD is essentially developed as a best practice for the DevOps space, continuous integration and deployment of applications. So it is more to do with the application development. So how are we going to adapt it and apply it to the data engineering side of things, right? So let's just probably have a look at what the cycle is, what the CI/CD pipeline looks like for the application development. This is probably not new to any of you because we always start with version control. If you think about it, as a software engineer, you join any team, you always start with configuring and setting up Git. As a data engineer, when you join a new team, that's not how it works, right? There is no strategy about going on version control with data at all. But then that's where, in the application development side of it, it always starts with version control, which is like source control of your data, or the source control of your source code, not the data. You build it locally, you do all the developments internally, like on your local machine, you unit test it, test it in the local machine, and then you deploy it into the staging environment, and then you run your integration tests. And once all of that goes through, you deploy it into production. And even after that, we continuously monitor for different OKRs and metrics and SLAs. Even if the software is running fine, we still have certain metrics that we need to adhere to. Now, looking at this, how can we adapt this to the data side of things, right? If you partition those several steps into 3 primary blocks, it would probably be build, test, and deploy, right? So at building, what we're trying to do is, like, the best practice is always to have source control, which we just talked about. And on the test side of things, we always have the test environments, where you spin up a test environment, do your test your fixes, and then it gets promoted to the next phase. And so having those test environments and isolated test environments is one of the best practices, or one of the pillars of CI/CD best practices in the application development side. Similarly, having the ability to automate these tests, because given the proportion of the scale of the application, there will be like so many number of tests, which one does not want to go about manually doing it. So there needs to be an automated way of doing that as well. And on the deployment side, obviously, there is this quality checks and reviews and PRs and everything that we do. And even after deploying it in production, we always have some mechanism to roll back to a consistent state or the successful state of the application. Now, adapting all these 5 pillars of best practices from application development exactly to the data engineering or the data development, this is what it would look like, right? Instead of source control, you would have data assets that are version controlled. Instead of test environments, we would have isolated test environments for data. But then, when you want to create isolated data environments, what does it even mean? With the test, with this application development, we had different infrastructure, like you spin up new container, test your fixes in there. But then in the data space, are you going to spin up a new container and copy your data into the new container? How are you going to create these, test environments? That is something we need to think about. Similarly, automating the tests, yes, like it translates directly from application development to here. And on the deployment side of things, quality checks are different from application development to the data engineering or the data lakes, right? In big data, quality has almost always been one of the biggest challenges for any data team for that matter. But then how do we ensure the quality and reliability of data before pushing it into production? We can adapt these principles from software engineering space, but how are we going to implement these in the data side of things? Automatic rollbacks also, for example, right? Like there has been so many number of times you look at a dashboard, there has been no errors, the pipeline ran fine, you got all your data into the dashboard, but then you look at the dashboard and you know that this data doesn't make sense. But then all the quality checks have been passed. The data is there because it was promoted from the previous phases successfully. So one definitely does need to go over effectively strategizing how does one define what is a quality data and how does one check those how does one test the quality of those things before promoting the data into production. We talked about the challenges. What can we do about those challenges? Go implement CI CD. But then how do we implement CI CD? Let's look at software engineering and see if we can adapt those principles. Now, this is how the data lakes look today. We have those principles from software engineering and we have our data lakes. So let's just try to apply them and see how we can do. The most challenges that we talked about is, what do we do when the production data gets corrupted? Yes. And modifying the pipelines and effectively testing them, a most common problem that we just talked about, and also the data quality issues. These are very common. I'm sure you all are, agreeing with these challenges that we face. And let's just start with the build phase, for example, because that's where we're starting, and say, we just said in the build phase, the most important thing is to have version control for data, right? So let's just go to the build phase. How do we do the version control for data? That is where Lakefs comes in. It is just an open source, data versioning tool that would help version any object store. You have S3 or you have any other, object store from other vendors. You could use Lakefs to effectively help you version the data. Let me just move on to this one, and it might probably make more sense. Let's say you have your data under a specific bucket, right? Let's say an ingest bucket, for example. And this is the repo that you create on top of your bucket. And on that, just like how you would create different branches in Git, you could go about creating different branches of data. Remember how we talked about creating different test environments and not having to copy the data around? Mock data, not so efficient. Copying all of production data, again, not so efficient. Here, just by branching out from the repo, you are creating an isolated environment and you have all of the production data available for you to do any tests that you want to run. You're not copying the data around, but you still have that isolated environment to run all your tests, right? And how does Lakefs go about doing it? It does a zero copy clone of all the objects that are in your in the specific bucket to create those branches. So it's not effectively copying everything from one to the other. It's just copying a bunch of pointers essentially, from that bucket just to create another branch. Like, to give you a better idea, probably, if this is, how it would look. For example, in the current setup, if you're using any of these object stores, Lakefs kind of sits on top of those object layers. It's just I would say, a metadata layer of some sort, because all the operations it does are metadata only operations. If you create a new branch, or you're committing it, or you're merging it to another branch, or when you even revert it to a previous commit, all of these are metadata only operations because it is not copying all the data from one branch to another branch. Simply it copies the pointers, you got a new branch, and every time you do a commit, it is also storing, for each of these commits, what are the objects that are, belong to that specific commit and everything. And it uses internally a Postgres DB to keep track of all these things. And it has also recently started using a KV store. So if you are an AWS user, you can even have an Amazon DynamoDB to take care of those metadata operations, to store those metadata operations. And let's say if you had your bucket in your S3, you would be accessing it like, S3, the bucket name, prefixes, and partitions and whatnot in your file. And just by having Lakefs on top of it, you would simply have to specify the branch name of where you want to read your data from, and your end customers or the end users or downstream analytics users, they could just go about doing their own existing workflows without changing a lot of, existing code and the pipelines. And how does it exactly do that? So what happens, let's say you are creating a new branch, but what happens when you're deleting objects in the new branch? Is it affecting the original branch? Of course, yes, because it is going to do a copy on write. So when you create a new branch, it is just copying the pointers. But when you're adding data to it, it is going to write it to a separate location that is going to be tagged to that specific branch. Similarly, if you're going to delete certain objects, it is going to be tied to that specific branch. So it does the copy on write and delete on write as well. And this is just specifically with respect to the version control, right? While building, we need version control to effectively collaborate with multiple teams. So if you think about it, all of us could simply be working on different branches of the same production data without risking production data at all. Lakefs also offers this branch protection policies, just like how Git offers branch protection. So you can have the production branch protected from any changes, like any external changes, and the data team can still be using production-like data for all their testing and development purposes, right? And moving on from the version control side of it to testing, like what are the two things that we saw in the testing phase of it, right? The first is to have the capability to create isolated test environments. And the second is automated tests, right? How do we run automated tests for data? To create the isolated environment is as simple as just branching out. Like lakectl branch create, that is your isolated environment, and you can do anything you want there. It's a simple one-line command. You don't have to it's not a expensive or a long-running operation at all. And you can be having the use cases for, how would one use a different branch? You can have a different ingestion branch where all your upstream data is going to come in, and you take that, do your ETL processes or run your ETL jobs, and only the process data goes into the production. And then you can also have, from the production data, there can be so many number of branches because different people from the team want to use the data. So from the production also, can there be multiple number of branches that go about for development purposes? So these are just a couple of use cases of how one could create these environments just by branching it out. And the next is to have automated tests. Lakefs also has a feature called Lakefs Hooks, which are very similar in functionality to Git actions. So you can have the triggers set, and once those triggers are met, it would automatically run a suite of tests that you had configured. That way, you are automating all the tests that you want to do on those data. And it is just like Git, right? It has branch, commit, merge, and also revert. So suppose if all those tests fail, like how your CI CD tests fail, and when you try to do a Git push or a Git merge, you can revert it back here as well. If the data does not go through these specific checks, always revert back, go to a consistent state, so your downstream users don't face data availability issues, right? They always have a consistent data available for them at any point in time without having to worry too much. And also think about the times where the first image where, it's one fine weekend, you're going to go grab a beer with your colleague, and then there is this data pipeline literally on fire that you need to fix. you can just revert to the previous day's data and be out and about, and you can always look to the production issue when you come back, and that way the data is in the consistent state. And I will be talking more about hooks on the deploy side of it as well, because it has more than one use cases. So let's just move on to the deployment side, where in the deploy phase, there are just two things, right? One is how do we do the quality checks before promoting data to production? The second, even after we deployed it, how are we going to make sure that we're monitoring and taking care of any issues that would come, and probably even troubleshooting those issues? Quality checks. First things first, like I mentioned before, they're similar in functionality to Git actions. So you can set up different triggers, like pre-merge hooks, for example. So anytime anyone in your team wants to do any merge of data into your production, you can have certain tests or the hooks set up. So only if those hooks pass through, the data will actually be promoted to production. A good example of that would be in the data engineering space, most teams would use specific formats, right? Parquet format or Avro or ORC. So you can say that only Parquet files can go in this production branch, this specific prefix, and ORC in only this branch and this specific prefix, and all of that can be configured, right? And imagine, since we were talking about the PII, GDPR, and the private data and everything, you can also say this specific branches cannot have, let's say, PII data. So any table with the columns names or credit card numbers or phone numbers cannot be present. It's essentially doing schema validation in some sense. Or you can have more sophisticated tests. For example, if you've used other testing suites like Great Expectations or Soda.io, or if you're using any other suites as well, you could integrate them as part of the Lakefs hooks instead of having to write your own custom schema validation and file format validation hooks. So it's really Lakefs offers the ability to run quality checks, automated quality checks on the data, but then it is giving you that freedom to actually decide from file format validation all the way to complex statistical validations and tests that you may want to run before you push or promote the data into production. So that is the flexibility and the feature that it offers. And one thing that I also wanted to highlight is that currently the Lakefs hooks is essentially running as a separate Python web server, which is run on a Flask app. So it's just a Python function which is reading the data and seeing if the file formatting is up to the mark before it is being pushed. But then you can have your own Flask app run anywhere, or you can even find its equivalent within the AWS ecosystem and run it from there as well. It's open for you to configure and run however the way you want, but then we have certain templates that are available for anyone who just wants to get started, which are written in the Flask app. And this is how it looks. For example, I'm not sure if you can read it from there, but then this is the actions.yaml file, which is the configuration of Lakefs hooks. And you can just give it any name, description, and all of that is fine. As you can see, it is the pre-merge hook. So before merging, you could check what needs to be checked. And only for specific branches you want to apply. So you could probably say main or production or whatever other branches. And so I mentioned the web server. So essentially, you want to mention the URL of the web server where it is running as well. And it is not necessary for you to apply these hooks and tests on all of the bucket. So you can specify if there is only specific prefixes you want to run these tests as well. And automatic rollbacks, because all of this can be done programmatically, so Lakefs can be used using a Lakefs CTL command, which is a CLI tool, and it also has a UI, and it also has Python SDKs and several other clients. We have integrations with almost Python, Spark, Kafka, and whatnot, like Airflow. You could check out the documentations page where we have number of integrations, meaning you can implement all of this programmatically and automate everything. So you don't have to manually do this every time for each of these workflows as well. So, okay. And by implementing all these 5 best practices we talked about, eventually we should be able to reach a place where our data lakes with the Lakefs will be in a good state where easily revert from the production issues. You can safely test your pipelines automatically, and also have that ability to create isolated test environments in all one line command, really. And let's just get to the demo quickly. Okay, I already have the Lakefs installed. Okay, so this is how the Lakefs UI looks like. I'm sure you can see that. And these are the different repositories that we have. Like, for example, Netflix is the repository that is built on this bucket, S3 Netflix. Like we will play around with this for the demo. As you can see, within here, we have multiple branches. There is one main. I created two other branches. One is the ingest, which is essentially the landing area for all your data. The second is main, which can be considered a production one. The third is the staging area where we would be doing all sorts of checks and running tests and everything, right? Let's just start with this, because an essential data engineering workflow starts with data in the landing area. Now what are we supposed to do with it, right? So we have a partition, and let's just say this is our file. I've just put a simple CSV file for the sake of an example. So this is the CSV file that we have, and I have within the main branch, and in the staging area, okay, so this is where Lakefs hooks come in, right? Remember the actions.yaml file that we saw, the configuration file? You eventually need to put them into Lakefs actions directory in whichever branch you want to validate, basically. I want to validate the data that is present in the staging area before merging it into main. So I have to create a Lakefs actions in this directory, put my actions.yaml here. Currently, I don't have any data because we have not run the ETL pipeline yet. So all our data is in the landing area. So let's go to the Jupyter notebook. It just starts with all, configuring Lakefs, installing the Lakefs Python client, making it easy for us to use Jupyter notebook to talk to Lakefs. And this is the repo and the namespace that we already have. If you can run this, you can see that there are like 3 branches already that we saw in just landing area, main, and the staging area. And it's the same. Okay. Now what I'm trying to do is, let's just read the data from the ingest branch, which is a CSV file, and this is how it looks. And in the YAML file, if you remember, what am I doing? Can you see it? Okay, so in here, the only condition that we have is that it will allow only Parquet files in production, right? So that's the only check that we have in our hooks. So we'll just go back to that. We have read the data from the ingest branch. Now we will write CSV files to the staging and see what happens. Let's go to the staging and see if our file is here. Yep, our file is here, which is being copied by the Spark job. Now let's just commit the file and see if it is being committed. Yes, it is also committed. Now when we try to merge, this is the staging area, right? We copy data from ingest to staging, but it is still in the CSV format. We committed also. We're now trying to merge it back from the staging area to the main area, like the production, which is obviously going to error out because we have the hooks configured. Okay, this is not the error that we want to see. Okay, main has uncommitted changes, so it's essentially like a git conflict, right? So there are uncommitted changes in main. Now what do you want to do? Let me just, yeah, so now there are no uncommitted. Let's just try to merge if the merge is going to happen. I just dashed the changes in main. Okay, so this is exactly what the error message we wanted to see, because it says precondition failed because pre-merge hook is aborted, and the condition is that if you see here, the server is running and format allows only par k and delta, and the prefix is also production, and our format does not support that. So you could be doing way more complicated tests as well, but this is just one example for the sake of a demo today for you to understand how Lakefs and hooks can be used. That's all I had for today. And do we have any questions or anything else that you want to know? And while we are doing,
does the data versioning require you to activate the S3 version control or something so that it?
No, not at all. Like Lakefs does not use a S3 version control or any of those artifacts for its versioning. It internally uses cryptographic hashing of these objects that are underneath. So it's not even versioning at the file level, it is versioning at the object level, like the binary level. So it does not need any, auxiliary or the peripheral versioning tools at all.
So if you delete the data out of that bucket, what would happen then?
Okay, so if you delete the data on that bucket, it would be out of that bucket, but then Lakefs also has this garbage collection rules where you can say, do you want to do hard delete or do you want to do soft delete? So when you do soft delete, it goes out of Lakefs, but it is still in your S3 bucket. But when you want to do hard delete, it will actually delete it from S3 as well, which is configurable for you within Lakefs, which I didn't touch upon because the focus was more on the quality test with the hooks part of it. But you can definitely check out more on our community page. It's Lakefs.io. And we are an open source project, and if this is something of interest to you and if you are interested in contributing or checking out the prototype, we have a playground. You could just spin it up and see what you could do with it, or you can also spin up a Docker container and see how you could use Lakefs. Build a prototype, just play around. Feel free to. And if you think this is valuable to you, you can also consider starting us on GitHub.
Batch processing pipelines or stream
Yeah, so far what we've seen is that most of our customers and the use cases who've been using Lakefs have been using for batch processing pipelines, because Lakefs sits on top of object stores. So any data that is in S3 is eventually it could be from streaming pipelines as well. Kafka could be writing to your S3 bucket, or someone else could be Flink could be writing to your S3 bucket. But it's the S3 bucket that we are interested in versioning. So if you know what I mean, it doesn't matter what the upstream process is going to be. Yeah. We are still going to version the object store. Great. It was great talking to you, and thanks for great questions.